you take a look at this diagram, did anybody notice a pattern in the dots themselves? The hat method. Can you see a pattern in the dots? Can you predict what the next picture is going to look like from the dots? Laura, can you come show us? And there might be more than one way to do it. Okay. So you're taking the last picture and you're arranging it into groups of, or a group of 4, and then you put a dot in the center. Okay, good. Did anybody see it a different way? Do you see? You don't have. Okay. So at 3 minutes, we're going to take this picture and we're going to make 4 copies of it. And then put 1 dot in the center. So in the chart, we have 0, 1, 2, 3, 4, 5, 6, and 1, 5, 21, 85. So what is the next picture going to look like? 4 of these. So it's going to look something like this. And how many are in each one of those? 85, 85, 85, and 85. So what is 4 times 85 plus 1? 341. Now I don't want to draw the next picture, but how am I going to find the next set of dots? So 341 times 4 plus 1, 1,365. And the next one's going to be 5,461. Okay. All right. So now for the recursive formula. So y sub 0 equals 1, and y sub n equals y sub n minus 1. How do we calculate every succeeding year? Times it by 4 and add 1. Is this exponential? Almost. If I were to get rid of this 1, then it would be exponential, because it would be times 4 times 4 times 4 times 4. But with that 1 on there, it's no longer exponential. It's kind of exponential and then add 1. Exponential and then add 1. Exponential, then add 1. Okay? So the explicit formula is a lot harder to figure out. Did anybody find a pattern in the numbers other than times 4 plus 1? So if we try the first differences, I have plus 4, plus 16, plus 64, plus 256, plus 1024. What's the last one? I don't know that one. 4096? Yeah, that sounds right. Certainly not linear. Okay, let's try quadratic. Plus 12, plus 48, plus 192, 192, plus, help me out, what is it? 768, and plus 3072. Well, that didn't help. And if I were to do this again, notice they start really small and they get big really fast. So even if I were to try the 3rd and 4th and 5th and 6th difference, we can kind of tell that it's not slowing down. So none of those are going to work. So I know it's not x to the 1st, I know it's not x to the 2nd, or x to the 3rd, or x to the 4th, or any other. It's not a polynomial. It's something else entirely. So I'm going to undo all of this stuff. Does anybody see a different pattern? CJ? Ooh. I'm impressed. I really had to beat my last class to get that out of them. A lot of people notice this is times 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So how many 4s are there in 256? Well, there's 1 4, 2 4s, 3 4s, and 4 4s. So another way to write 256 is 4 to the 4th. How many 4s are there in 1024? 5, so that's really 4 to the 5th. Does everybody see that? So how much am I going to add in 10 minutes? 4 to the 10th. Now, does that tell me the total number of dots? No. That tells me how many additional dots there are. So we could actually change our recursive formula, and you don't need to, but we could say y sub 0 plus 1, y sub n equals y sub, that's a y sub n minus 1 plus, how much do we add on any year? 4 to the n. Which is really strange. These two equations look different, but they accomplish exactly the same thing. So there are two different recursive formulas, and sometimes that happens. Okay, so what I want to do now is figure out the total amount added. I no longer want to just talk about the new amount, I want the total amount. So what we need to do, instead of using last year, we just need to line up all of the additions. So for year 0, we take 1. Well, minute 0. For minute 1, we do 1, and we add that to 4. 4 to the 1st. And for minute 2, I'm going to take 1, and I add that to 4, and then I add, what comes after that? How much do I add on minute 2? 16, but 16 isn't how I want to write it. I'd rather write it as 4 squared. Okay? So for 3, 1 plus 4 squared plus 4 to the 3rd. Do you see the pattern? Is that recursive? What does it mean to be recursive? How do we define recursive? How do we tell if one thing is recursive and another thing is not recursive? I'm glad I asked. I'll let you think about it for a second. Anybody know? Nobody? Oh, good. A recursive graph has dots. Good. Why are recursive equations sometimes not a good idea? When does a recursive equation cause problems for us? That's the definition of recursive, knowing the one before. So if I wanted to know the 100th minute, I'd have to add something to 99, to 98, to 97, all the way back to the beginning. So recursive equations do not allow you to find any value in the future without knowing all the values in between. Okay? So if I said I want to find what y equals in year 10, what is year 10 going to look like? Well, 1 plus 4 plus 4 squared plus 4 to the 3rd plus 4 to the 5th plus 4 to the 6th, plus 4 to the 7th, plus 4 to the 8th, plus 4 to the 9th, and plus 4 to the 10th. Did I need to calculate 9 in order to write that? No. So is this recursive? No, it's not. But I do have a problem. If I want to find 50, I'll have 1 plus 4 squared, and now I'm getting really lazy. So this is what we do. We know that this is going to stop eventually. And we know that those 4's go in order. 4 squared, 4 to the 3rd, 4 to the 4th. So we do this. Plus, dot, dot, dot. And then I usually write the last two terms. What would the last two terms be? Plus 4 to the 49th, plus 4 to the 50th. So that's what it would be. Now, calculating that is going to be a little bit of a pain, but I do know exactly what 50 is going to equal without calculating anything before. So here is the explicit formula. If I want to find for year n, y equals 1 plus 4 plus 4 squared plus dot, 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 what are my last two terms going to be? Good job. So my last one is 4 to the n, because this value and that value match. And then what's going to come before n? 4 to the n minus 1. Now, what if n is 0? What's my answer going to be? 1. It's just the first one. What if my n is 1? Then it's just the first two, so it would be 5. So even though the equation is bigger than that, we don't care. We just say stop. That's 0, that's 1, that would be 2, and so on. Now, that is the explicit formula, but there's a problem. How do I graph that? You can't. Because every time you change x or n, it adds another term or a number of terms. Okay? Now this is beyond the scope of this class, but next year you're going to figure out an equation that smashes all of this down to just a few numbers. And this is what it looks like. Y equals 1 minus 4 to the n divided by 1 minus 4. And that is the explicit formula. And you're not going to learn that this year, but you'll learn that next year. So what you do is you put this number here and here, and then you put the n value right there. So if my equation was 1 plus 0.5 plus 0.5 squared plus 0.5 to the third, dot, 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 then the formula would be 1 minus 0.5 to the n over 1 minus 0.5. And all you have to do is plug in n, and it will give you the total for any year. Okay? All right. Should be ready to hand that one in.